As a solutions architect, you should know SLA by any means. So let us define what SLA is. So it's a contract between service provider and customer that defines the level of service expected from the service provider. For example, suppose I am a service provider of, say, in a restaurant. I provide food service. No, now I say that my food would be clean, that would be hygienic, and that would be tasty. That is my SLA, or those are my SLAs. If any of these SLAs are breached, for example, if my food is not tasty, or if my food is not hygienic, then I'll pay some penalty to the customer. So me as a service provider would be levied a penalty to the customer. So similar is the case here. If an SLA is missed, penalty can be levied on the service provider. So in our case, AWS is the service provider, AWS is cloud service provider. So every service in AWS should have an SLA in it. Again, depends on the service provider. They might define SLA, they might not define SLA also. Now, when you are creating an application or when you are building a solution using AWS, you have to keep SLA in mind. So if you are using, say, for example, EC2, AWS says the AWS provides a service commitment or a service level agreement of 99.99% uptime for EC2. That is not 100%. So you have to make sure when you design your application or when you design your solution, you have to take that SLA into consideration. So let's see how SLA works with an example. Suppose I have an uptime SLA for a server in corporate DC. This is how I define to my end users. So I have a product and that product is being hosted on a corporate data center. And during the agreement with the customer, I say that I'll be providing you this much of uptime SLA monthly. These are the different SLA percentages. I say that my uptime SLA is 95% monthly. So that means I have a total of 43,200 minutes in a month. So I'm saying if my uptime SLA is 95%, my server might be down for 2160 minutes or 36 hours. That means in a month, I can have a downtime of 36 hours. And if you agree as a customer to this, then it's okay. And 95% SLA is very low. No customer would agree for 95% SLA. Let's say 99% SLA. In 99% SLA, we get a downtime of 432 minutes or 7.2 hours. That is also huge. So suppose you are hosting a website in a corporate data center and you say that my uptime SLA is 99%. That means I can have a downtime of 432 minutes or 7.2 hours. Think about it. If your web server is down or if your website is down for 7.2 hours and your website is being used throughout the globe, and if you give a 7.2 hours of downtime per month, of course you'll lose business. What about 99.99%? So if you say our SLA is 99.9%, that is my uptime SLA, I'm saying that my downtime would be 43.2 minutes. That's less than an hour. That is also not good. 99.99%. So if I say my uptime SLA is 99.99%, I'm saying that I'll have a downtime of 4.32 minutes. That might be agreeable. So in a month which has 43,200 minutes, I'm saying that I can have 4.32 minutes of downtime. Remember something, that is can have. It's not that I'll have the downtime for sure, but yes, if I have downtime, I would not be having more than 4.32 minutes. So before going further, how did I came into this downtime figure? So if your uptime SLA is 99.99%, that means your downtime is 100 minus 99.99 or 1 minus 0.9999, that is 0.00001. So if you multiply that with the total minutes, you get 4.32 of downtime. So that's how downtime is calculated. It's pretty simple. It's 100 minus uptime SLA divided by 100, and then you multiply that with the total time available. So in our case, the SLA is monthly, so the total time is 43,200 minutes. That's the number of minutes in a month, considering that month has 30 days. So in 30 days, I might get a downtime of 4.32 minutes if my uptime SLA is 99.99%. Now let's see a few more examples. Suppose I have a requirement, I have to create a service or a product, and my customer is saying that my downtime cannot be less than 1 minute per month. So the maximum downtime that customer can afford is 1 minute. So that means 1 minute. So 1 minute downtime, that comes out to be 1 by 43,200, that is equal to 0.0000231 or 99.9977 uptime percent. So how did I come to this figure? You subtract this figure from 1 and multiply that by 100, right? So because we have divided the downtime by total number of time, so this is the amount of downtime we can afford, that is 0.00231% or uptime of 99.9977%. That is, in a month we need to have 43,199 minutes of uptime minimum. So how do we come out? Let's say we take a server with 99% of SLA uptime. So that means we'll see how many servers would be needed to get this uptime, SLA uptime, if one server has 99% SLA. That means out of in a month, I'm saying I can have a downtime of 432 minutes with one server. Of course, I cannot use this single server. Let's see another table. We have 4 columns here: number of servers, then downtime probability factor, then downtime in minutes, and what is the time when at least one of the servers is up. What is this downtime probability factor? So that is the probability of all the servers going down except one. That means if I have, say, 10 servers, what is the probability that 9 servers would be down bearing one server? So that is downtime probability factor, and using that we calculate something called downtime. That is very, very simple: total time into downtime probability factor, and then we find out what is the amount of time at least one of the servers is up. So if you go back to the question, it says my downtime cannot be less than 1 minute per month. That means for 43,199 minutes, I should have at least one server up. So if at least one server is up, that's not down. So that is up, right? So okay, now we are using a server which provides 99% uptime SLA. That means that server can be down for 432 minutes in a month. What if we use only one server? So in that case, our downtime probability factor is 1 minus 0.99 equal to 0.01. Why this figure? Because we are using one server which provides a uptime of 99%. So 1 minus 99 by 100 equal to 1 minus 0.99 is equal to 0.01. So a downtime of 432 minutes or an uptime of 42,768 minutes. That is nowhere near to this figure. Of course, because we are using one server and the probability of one server is down is 432 minutes. What if we use two servers? So in this case, downtime probability factor is downtime probability factor of one server into the downtime probability factor of another server, that is 0.01 into 0.01 equal to 0.0001, or a downtime of 4.32 minutes. That is total time into downtime probability factor. So what is the amount of time where at least one of the servers would be up? Total time minus this one 4.32, that is equal to 43,195.68 minutes. Again, that is not near to this one. So our SLA will still not be met. What if we use 3 servers? So downtime probability factor would be 3 times 0.01, and it comes out to be 0.000001. That means this is the probability that all the servers would go down bearing 1 if we use 3 servers. That means I can have a downtime of 0.0432 minutes. The amount of time at least one of the servers is up is 43200 minus this one, which comes out to be 43,199.957 minutes. To meet our SLA, you have to use at least 3 servers. If you use 2 servers, that is not meeting our SLA, because the minimum time, that is one of the servers would be up, is coming out to be 43,195 minutes. So we'll have to use 3 servers. If we use 3 servers, we can guarantee that we'll have at least one of the servers would be up for 43,199.957 minutes. So we'll have to use 3 servers to get this SLA. This is almost equivalent to 100%, but this is not. It will give you 5 nines of uptime SLAs, not 5 nines, maybe 7 nines of uptime SLA. So you'll have to consider all these things. Remember this thing, go through it again if you have not understood. So I'm repeating, downtime probability factor is the probability of going all servers down bearing 1 or except 1. So if you have one server, and if a single server provides you an uptime SL of 99%, then the downtime probability factor is 1% or 0.01. So if you're using 2 servers, it will be 0.01 into 0.01 equal to 0.0001. So this is a probability factor of all servers going down except 1. So as we are using 2 servers, this is the probability that one server will be down but the other server will be up. So you get this downtime probability factor. From this, you calculate the downtime. So the downtime would be total time into the probability factor, and the uptime would be uptime of at least one servers would be up is equal to total time minus downtime. So you need 3 servers, each having 99% of uptime SLA to solve our purpose.